In this module, we are going to see what the relationship between limits and continuity are. Since the definition of a limit was more or less almost exactly the same as the definition of continuity, it is no shock that both are intimately related to each other. The theorem is as follows. Let f from a to r be a function, and let x in r, not x in r, x in a be a limit point. Note, I am taking x in a because I am going to talk about continuity at the point x, and you can talk about continuity at a point only if that point is there in the domain. Whereas to talk about limits, you need not require the point x to be actually in the domain of f. That's not essential. Then f is continuous at x if and only if limit y going to x f of y is equal to f of x. A function is continuous at a point if and only if the limit as you approach that point is equal to the functional value. If you recall, a slightly more elaborate version of this is what was used as the definition of continuity in school. The left hand limit is equal to the right hand limit is equal to the functional value. Right? Let's prove this, and the proof is not hard. Assume that f is continuous at x. Fix epsilon greater than 0. Then there is delta greater than 0 such that if y is in a and mod y minus x less than delta, then mod f of x minus f of y is less than epsilon. Right? This is just the definition of continuity, which I am writing down for the 17th time if my count is correct. So what does this mean? Well, this means limit y going to x f of y is f of x. It's word for word the same thing as the definition of limit, except that 0 less than mod y minus x is less than delta is missing, but who cares? And this statement says more than what is required for me, right? So immediately from the fact that f is continuous at x, it immediately follows that limit y going to x f of y equal to f of x. Okay, what about the other direction? Suppose limit y going to x f of y equal to f of x, and I have to write something down for the 18th time now. Fix epsilon greater than 0, then I'm practically getting bored of this. Something if mod 0 less than mod y minus x less than delta, then mod f of x minus f of y is less than epsilon, right? But this is exactly the same as the definition of continuity, except the point y equal to x is allowed, but at y equal to x, this inequality is easily satisfied because mod f of x minus f of x is 0, right? So this means the definition of continuity at x is satisfied because mod f of x minus f of x is 0. That's why, right? So because the definitions were so similar, it is sort of trivial to see that continuity and limits are intimately tied to each other. This is a course on real analysis, and you have just watched a module on the relationship between limits and continuity.